Hello everyone. In this next video we're going to discuss how to solve quadratic equations via completing the square. And we've talked about a number of methods for solving quadratic equations thus far. The main couple being solving via factoring, solving via the quadratic formula, and also we've talked about solving by extracting square roots, but that depended on our equation taking a particular format, meaning we have to have something squared equals a number, kind of like this first equation I'm highlighting here. Comparing that to the second equation in the paragraph, we would have to rely on the quadratic formula for that second one up to this point. The question would be, can we solve the second one that I've highlighted in yellow like the first one, where we could just get the square off by extracting square roots? Remember, we always have to get two solutions when we solve the square roots though. And it turns out, yeah, we can rewrite the first equation algebraically to look more like the second equation, the second equation to look more like the first equation, and then solve that one also by extracting square roots. And in fact, the quadratic formula comes from completing the square. So it's kind of a more fundamental identity than just the quadratic formula. Just as a quick reminder, we've seen this picture before. When we think about y equals x squared versus y equals c, thinking about the equation x squared equals c, if we let y equal the left hand or the right hand side, we are reminded that we get two solutions to an equation like this because there's 2 points of intersection on our graph. And again, when we take those, when we extract the square roots, we cannot forget that this really does mean two possible solutions, one coming out to be the positive square root, one being the negative square root of that number, c, capital C. Alright, so let's keep that in mind. We can't forget to take the plus and the minus portions when we do this process, even by completing the square. Now, what are the steps going to be? I've listed them out here. Get all your x terms on one side. If the coefficient in front of x squared is not equal to 1, then we need to force it to be 1 to apply the completing the square identity we've discussed in the previous video. Then do the process. Divide the coefficient of x by 2. Take that special number, square it, add and subtract it in to the left hand side, or to the side with the x's on it. Or what you could do is you could add that number to both sides. Alright, so instead of adding and subtracting it on one side, you could just simply add it to both sides. If we're dealing with an equation, we cannot do that if we're dealing with an expression like we talked about in the previous video. There we would have to add and subtract it. And here we can, because we have an equation, we have two sides, we can simply just add it to both sides. Use the completing the square identity to rewrite the expression as a perfect square quantity, a binomial being squared, and then we're going to extract square roots. Alright, so let's get into some examples. This first example, the x terms are already on the left side. The number in front of x is -8. Dividing that by 2, we get -8 divided by 2, which is -4. So, okay, let's rewrite the left-hand side by completing the square. So what do we do here? Well, let's take it below. Okay, so the left-hand side is x squared minus 8x, and what we've done in our previous videos is add -4 squared and subtract. So I'm going to do the same thing we've done prior, and then I'll just explain why it's equivalent to adding to both sides. So then we're going to subtract -4 squared, and then that would equal 20. Okay, let's do the next couple of steps. Alright, now we know from our previous experience here that these first three terms become the perfect square binomial. It's going to be x plus -4, which we can just write as x minus 4 quantity squared. And then we would have minus -4 squared is positive 16. Now, if our goal is to isolate x in here, because we're trying to solve this equation up here for x, we want to know what numbers do you plug in for x to make that a true statement. Well, we want to get the x minus 4 part by itself. So at this stage, we would add 16 to both sides. Now, that shows right there why we could have, from the get-go, instead of adding and subtracting it on the left side, we could have just added -4 squared, which is 16, to both sides. So either way you want to do that for solving equations via completing the square is fine. When you're graphing or just completing the square for an expression, though, we would have to add and subtract it into the expression. Alright, now we have it into the format that we want it in. Alright, so again, notice there's no x squared term separate from an x term. It's one binomial involving x minus 4 squared. To get the square off, we have to extract square roots. And a lot of times you're going to see this written in a compact form by writing x minus 4 equals plus or minus the square root of 36, which we know is 6. All right. But just keep in mind that means two separate things. All right. So you need to separate this out, all right, at some point, and rewrite this as x minus 4 equals negative the square root of 36, and separately x minus 4, because it's a separate solution, equals the positive square root of 36. Now we know that the square root of 36 is 6, so we would really have equals negative 6 or positive 6. Now for this one, the numbers, if we now solve for x by adding 4 to both sides, in each case, the numbers are coming out to be nice. They're coming out to be a 10 in our case and negative 2. Okay, so we got integer answers, 10 and negative 2. That would just tell us this particular example could have been solved via factoring. All right, let's just review the steps though here. Again, get the x terms on one side if you need to. There, it's already done. Complete the square. Take the coefficient of x. All right, as long as the coefficient of x squared is positive 1, we can do this. And divide the coefficient of x by 2. We got negative 4. You can square it and then add it and subtracted it on the left side, or just add it to both sides. And then you use the completing the square identity to rewrite that as one expression squared, and then extract square roots. Just don't forget we get two solutions here. So this is an alternate solution method for quadratic equations. Okay, we'll look at a couple more examples, and that will be it for this. All right, so next example we're going to do x squared plus 4x minus 11. I'm just going to mention if you tried to solve that by factoring, you'd have to subtract 11 from both sides, and then you'd have the equation x squared minus, or I'll just write it actually off to the side here. We would have x squared plus 4x minus 11 equals 0. It does not factor though. There's no factors of negative 11 that add up to positive 4. Alright, so it's not factorable. So what we've learned so far this semester would be then saying, okay, you got 0 on one side, and then if it's not factorable, apply the quadratic formula. This is a different way to do it via completing the square. So again, our coefficient of x squared is positive 1, so we can just look at taking our coefficient of x, which is 4, dividing it by 2 to get 2. That's what we're going to add. We're going to square and add and subtract in to the left side. I'm just going to keep doing it that way for the video. Again, you can add 2 squared to both sides. That would be equivalent to this. But just to stay consistent with what we did in the previous video, again, these first three terms become x plus 2 quantity squared. And then we get minus 4 equals 11. And then, again, what we're going to do is now isolate x. We're going to solve for x by getting the x expression by itself. We want to do that by removing this 4 term from both sides. So we're going to add 4 to both sides. And then we get x plus 2 squared equals 15. Now 15 is not a perfect square, so we're going to get not as simple numbers here as we did in the last example. But again, don't change your process. Take the square root of both sides, extract square roots. We get x plus 2 is equal plus or minus the square root of 15. And then subtract 2 from both sides to isolate x. I prefer to write the negative 2 in front of the square root, so it's negative 2 plus or minus the square root of 15. We just can't forget, if we were being asked to give the decimal value for these solutions, we would need to record 1 with the minus sign, and then separately 1 with the plus sign. Alright, we're used to that from our work with the quadratic formula before, so I'm not going to go through and compute those decimals, but you could compute those decimal values there also. Alright, let's do one more example, and I'm going to take one from the homework. This is question number 5 in section 6. So that's homework 6 in unit 3. Number 5. Alright, so this one's a little tougher problem where we're going to solve it using the completing the square process, and it forces us to write it into the format that we're looking for. And just be aware that these numbers are not going to be that simple. D and E, capital D, capital E here. It's saying, you know, or into this format, all right, depending on whether D comes out positive or negative. All right, and that's what we're answering in the first part of it. The second part, solve the equation. All right, so that's our ultimate goal, is to solve the equation. So let's rewrite that down below, and then we'll get at it. All right, now this one is going to be more painful in terms of the complexity, because the coefficient of x squared is not equal to 1. All right, so first thing we want to do, subtract 10 from both sides. Let's just get that out of there. Again, different than what we saw in the last video, because we have an equation here, so we can move numbers to other sides of the equation. All right, so we get negative 10 over on the right side. And just buckle up. If you need to watch this a couple of times, go ahead. Now, we have to factor out 3 from both terms on the left side. All right, now when we do that, we get x squared, but then we'd have to, because dividing 3 by 3 would give us 1. Now 11 is not divisible by 3, so when we do that on the second term there, what we're going to see is that we need to get 11 over 3. We have to just deal with that. All right, now what's going to be a little different in solving this equation versus what we did in a previous video where we had to kind of rewrite by factoring out a number. Here, because we have an equation, we can actually divide both sides by 3 to cancel this 3 out. And that makes our left side simpler. We get x squared minus 11 over 3x is going to equal negative 10 over 3. Okay, now we go to work on completing the square. So just be aware your numbers are going to be more difficult. The coefficient in front of x squared for this one is negative 11 over 3. So we got to take that and divide it by 2. Keep in mind that's like multiplying it by 1/2. So if we think about that as 1/2 times d, it's 1/2 times negative 11 over 3, which is going to give me negative 11 over 6. That's our special number that we then need to add and subtract in on the left hand side. So let's do that now. We get x squared minus 11 over 3x, and we're going to do plus negative 11 over 6 squared. And again, just for consistency, I'm going to keep doing it the way I have been, which is to subtract it off on right afterwards, and then eventually we will be adding it over to the right side, but we'll do that in the following step. Now, like we've seen many times, these first 3 terms become the perfect square binomial. Not very pretty for this example, but okay, we just got a deal. We get x minus 11/6 all squared, and then we're going to get minus what number here? When we square negative 11, we get positive 121. Squaring 6, we get 36, is going to equal negative 10 over 3. All right, now in the problem, it wants us to write x plus or minus a number squared equals another number. So our job now would be to add over 121 over 36 to both sides. All right, now I'll just rewrite, just to save a little time here, this right hand side. 12 times 3 is 36. We would want to multiply both top and bottom by 12. That will give us, in this problem, negative 120 on the right side over 36. All right, now when we add 121 to the negative 120 over 36, our right hand side now becomes positive 1 over 36. Right, so our denominator stays the same. Adding our numerator, we get 1 left over there. And then we have x minus 11 over 6 squared. So that actually is the answer to the first part of the problem. All right, you actually have to type, the left side in the first answer blank, the right side in the second answer blank. Now we're going to extract square roots. So we get x minus 11 over 6 is going to equal, taking the square root off, or the square off. We got to do that by taking square roots, but we can't forget we get 2, a positive and a minus, a plus and a minus. So now we can square root factor by factor, or quotient by quotient. We can now do a little better here. Our right hand side is actually somewhat simple for this example. It actually comes out to plus or minus 1 over 6, because 1 and 36 are both perfect squares. Now adding 11/6 to both sides, I'm just going to do it for brevity for the video. Now what we need to do is just separate this out, one with the minus sign, one with the plus sign, so we get 11/6 minus 1/6, and separately 11/6 plus 1/6. Alright, and what does that give us then? It gives me 10/6, which we could simplify down by dividing the top, taking the constant factor, or the common factor of 2 out of the top and the bottom, as 5/3. The other one, we get 12/6, which comes out to 2. Alright, so we get 2 rational number answers. That would indicate to us this would have actually been a factorable quadratic equation to solve. Alright, that's it for this video.